Now we're done with defining angular momentum. We have defined the angular momentum for a particle. We also defined an angular momentum for a rigid body. The question now is, do these equations make sense? Kasi ang ginawa lang natin, medyo heuristic. Kasi nag-R cross something lang tayo and okay, ito yung define nating angular momentum. The question is this correct? Okay? Doon natin babalikan yung Newton's second law natin. So let's go to conservation of angular momentum. So taking the time derivative of the angular momentum, we see that. So what I will do is I take the expression dl vector dt. So first, I will use the definition of a part of an angular momentum of the particle r cross p. And then from there, I can say that this is just the time derivative of r cross p. Tama? Tama? Ano lang naman yan, definitions lang. Then remember that in calculus, when you differentiate a product, may product rule na tinatawag. Pero for vectors, ganun pa rin yung product rule. So parang first the second, plus second the first. But instead of just usual multiplication, you have cross products. And dapat tama yung ordering. Kasi nga, remember, the cross product is anti-commutative. So kapag binaliktad mo yung p tsaka r dyan, magbabaliktad yan. And hence, I can write this as just first, second the first muna. Actually, hindi matter yung addition, yung cross product relation ang matter. Cross p hat plus r cross dt dt. Tama? 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 Gets to? Basically, what I did is, remember your product rule, derivative of fg is f prime g plus fg prime. Tama? Naalala yan? From your calculus. Okay, ganun lang din yon. Cross product nga lang siya. Okay, but what is dr dt? Okay, again, what is the time derivative of your position? What's the time derivative of the position?
Velocity.
That should be velocity cross, but what is momentum? This is just mass times velocity, right? Tama? Right? Tapos plus r cross, what's dp dt? What's the time derivative of momentum? From Newton's second law, this is just equal to what? This is your f, right? So this is r cross f. Tama? But what is the cross product of a vector with itself? Ang dot product, magdodoble, maging a squared. Pero anong cross product ng sarili ng dalawang vectors na equal? Ano lang yan? This should be 0, right? 0 yan. Isipin nyo, parang v, magnitude of v, sine of the angle between them. But what is the angle between two equal vectors? That's 0, right? Tama? So v cross mv is 0, and hence what we have here is dl dt equals r cross f. But what is r cross f? Ano yan? Ano lang yan? Di ba yan yung torque? Tau? Tama? Tama?
Yes, sir.
Therefore, we have shown that the angular momentum, or I should say, the torque gives you a change in the angular momentum of a body. Tau is dl dt. So it makes sense. The equation makes sense because we have obtained an expression for Newton's second law in rotational motion using the definition of the angular momentum. Tama? Gets? Gets ba? Nakuha? That's true for the first expression. What about the second expression? So remember, for a rigid body, we use Newton's second law of rotation. Okay, what I will do is dl dt ulit. This is simply d dt using the second definition. This is just I omega. Tama? And therefore, remember, for the meantime, our moment of inertia is constant. Therefore, I can take it out of the integral and of the derivative, sorry, and say that this is just I d omega dt. Tama? But what is d omega dt? What is that? This is the angular acceleration alpha. So we have I alpha vector, and hence, by Newton's second law of rotation, what is this? So, ano lang yan? Still the torque. Therefore, torque is vector is dl dt. Hence, the two equations are correct because we have obtained our Newton's second law of rotation, because that's what our objective is. Our objective is to obtain an analog of Newton's second law of rotation, now expressed in a quantity instead of similar to f equals dp dt. We have we want to have an expression that relates the torque with some quantity, which is what we know as the angular momentum. Meron tayong nakuha expression na ganyan. Therefore, what we defined earlier as the angular momentum is correct. Okay? Kaya ganun siya dinefine. Kasi lumabas itong expressions natin for angular momentum. Malinaw ba yun? Okay. So, in a way, the net external torque exerted on a body changes its angular momentum given by, for the linear momentum, it's just dp dt. For angular quantities, is the tau is dl dt. Questions? May tanong? May tanong ba rito? May tanong? Wala? Wala?
None po.
None. Okay. Now, so in a way, torque and angular momentum are related. So there is, if tau and L are pointing in the same direction, then L will increase in magnitude. If tau and L are pointing in opposite directions, then L will decrease in magnitude. And if tau and L are perpendicular to each other, then L will change its direction. So these are some of the relationships between the directions of the torque and the angular momentum. From the relationship, tau is dl dt. Okay? Questions? Questions? Again, change ang torque ay change in the angular momentum of a system. Questions? May tanong? May tanong? Wala? Okay. Now, what if the torque is 0? If the net torque is 0, then dl dt equals 0. And remember, ito na naman tayo, kung meron kang the time derivative of something vanishes, then that quantity should be a constant quantity or a conserved quantity. And hence, if the net external torque acting on the system is 0, hence the angular momentum of that quantity is constant. And thus, we have, for a system of I-rigid bodies, the transitions from state 1 to state 2, where the net external torque is 0, we have conservation of angular momentum. The initial angular momentum is equal to the final angular momentum. And hence, you can write it as simply the sum of the individual angular momenta of, this is for rigid bodies though, is equal to the sum of the final angular momenta of these rigid bodies. Okay? Questions? That's basically conservation of angular momentum. From the definition of the torque, or from the Newton's second law of rotation expressed in terms of angular momentum, we have obtained a conservation of angular momentum provided that the net external torque acting on a system or on a rigid body or a set of rigid bodies is 0. And hence, we state the conservation of angular momentum as follows. If the net external torque on a system is 0, then the total angular momentum of the system remains the same. That is, the total angular momentum is conserved. Okay, malinaw? Malinaw ba to? Again, we're only talking of the net external torque. Hindi kailangang walang torque. Pwedeng may nag-act na torques, pero dapat nagka-cancel out. Magkaiba yon. Pwedeng may mga torques, pero nagka-cancel out yung mga torques mo. And therefore, the net external torque for in that case is 0. Okay? Sige. So, if this expression is satisfied, then angular momentum is constant. One way to visualize this is, for about si Einstein dito, umiikot siya sa isang turntable. By changing the moment of inertia, his moment of inertia, ang ginawa kasi niya from a large moment of inertia, maliit yung angular velocity. Pero dito, maliit yung moment of inertia kasi pinalapit niya sa axis of rotation niya eh. Malaki yung angular velocity. And therefore, in that case, angular momentum is always conserved. Pag kinurl mo yung fingers mo, bibilis yung speed ng rotation mo. Okay? So yun. Questions? May tanong? Are there any questions?
None, sir.
None. Thank you. Sige. Okay.